All. This is Dr. Mobeen Sayed from drbeen.com. Welcome to one more show. So, right off the bat, NeoCov is a bat coronavirus. It is a relative of MERS-CoV, Middle East Respiratory Syndrome virus. It is not seen in humans. There is no human transmission. There is at this time no concern for this virus. There is a preprint in which there is an in vitro study for the modified cells where the researchers used the NeoCov, which is an older variant. It's not a subspecies of Delta or the Omicron or SARS-CoV-2. It's a species or a variant of MERS-CoV. It was actually seen in 2012, then in 2015. It does not use human ACE receptors. So, in summary, it is not a concern at this time. However, it has become a concern because this preprint that I'm going to show you that came up. Then, based on that preprint, the news media started running with it, and now we have a concern out there as well. So, let's look at the preprint together. As good cool beans, we John Snyder is funny. So John says MERS-CoV too. Yeah, so I think we'll be fine. So here, so before I present this study, let me show you another thing before. So let's say this is a spike protein. Again, this is not MERS-CoV's spike protein or NeoCov spike protein, but just generally in a spike protein. Or let me actually draw it as well. So let's say here we are. This is a spike protein, right? So on this spike protein, we know that there is an S1 unit, which then has a receptor binding domain, and then we have an S2 unit. Good. And we know that for human coronavirus, the SARS-CoV-2, not human coronavirus, SARS-CoV-2 binds with ACE2, human ACE2. Of course, it was able to bind with the bat ACE2 as well, or bat some receptor, but it binds with the human ACE2. We all know that. On every protein that we encounter and that we have, every protein has a carboxy terminal or a carbon side. Every protein is actually a chain of amino acids. Every amino acid has a C terminal or carbon terminal or carboxyl terminal and a nitrogenous terminal. So when you string them up together in a chain, let's say if these are just the chains, then one amino acid's carboxyl and the other amino acid's nitrogenous side would stay empty. That is what is called the carboxyl terminal or C terminal or N terminal. Researchers have said that for this bat coronavirus, which is not found in humans, which is not seen to be transmitting to humans, what they did was they saw a modification, or they did a modification to the C terminal. And when that modification was done, then it improves the affinity of the spike protein of NeoCov to ACE2. But basically, that is the affinity for bats ACE2, not for human ACE2. It actually cannot work with human ACE2. And to work with human ACE2, this virus would need a lot of modifications. It would need to be in humans for some time to continue to work with us. But it cannot just start doing that right away. So that is a basic structure of the discussion. Now let's go to the study itself. In this diagram, if you see, this is the spike protein's ribbon structure, and this N and C here, they are the N terminal, the green dots, and the C stands for the carboxyl terminal, or the C, the black dots. Just something to keep in mind. Now let's look at the preprint. So this is the close relative of MERS-CoV in bats use ACE2 as their functional receptors. So here is the study. I'm just going to go over this much. It's actually, we shouldn't even have been in this state that we are running with these kind of news, but I wanted to make sure that we are at least aware of what's happening. Middle East Respiratory Syndrome coronavirus, so MERS-CoV, and several bat coronaviruses employ DPP4 as their functional receptors. This is a general statement that bad coronaviruses use DPP4. Many of them. There are some that use ACE2 too. So good, understood. However, the receptor for NeoCov, this was found in 2012 and 2015 too. It's not a new virus. It's not a variant of Delta or Omicron. The receptor for NeoCov, the closest MERS-CoV relative, yet discovered in bats, remains enigmatic. So, well, that's fascinating. Okay. In this study, we unexpectedly found that NeoCov and its close relative, another CoV, can efficiently use some types of angiotensin converting enzyme 2 and less favorably human ACE2. And I forgot to speak the most important word in here, bat. Some types of bat ACE2 and less favorably human ACE2. So anything that will work with bat ACE2 would work less favorably with human ACE2. This is not something that is dangerous at this time, unless if it is made dangerous, that is different. Look, even with these viruses that has, for example, SARS-CoV-2 jumped into us, there still has to be a lot of research done that how did it just arrived in human body and started working with it. We are fortunate here with the NeoCov. So let's say we want to say that, well, this is a dangerous thing. Fine, let's call it dangerous, but then we agree that the ACE2 it binds to is bats and not humans. The two viruses use their spike proteins, S1 subunits carboxyl terminal, that is what I just explained, for high affinity and species specific ACE2 binding. So they should have actually said over here bat specific ACE2 binding. So they're simply saying that, hey, it has a change here on the spike protein that allows it to efficiently bind with the bat's ACE2. Fine. Why are they saying this? They're saying this that normally it is supposed to be binding with DPP4 and not with the ACE2s. But it seems like this one can bind with bat's ACE2 as well with some efficiency. That's what they have discovered. Then they say cryo-electron microscopy analysis revealed a novel coronavirus ACE2 binding interface in a protein glycan interaction distinct from other known ACE2 using viruses. We identified a molecular determinant close to the viral binding interface that restricts human ACE2 from supporting NeoCov infection, especially around this. So check this out. Here, what are they actually saying? Here they're actually saying that, hey, it will not happen. We identified a molecular determinant close to the viral binding interface that restricts human ACE2 from supporting NeoCov infection, especially around the residues. So they've then given the amino acid's name where the resistance is. So what will happen is folks like me will come in and say, look, here is the actual situation. It's not really a big problem. But the media would run with the headlines to say, here we have a new concern. What will they base it off? They will base it off of the last statement in this study. So we'll look at that statement too. So here, so far, authors have said, hey, we found something that can bind with the bat's ACE2. It does not bind with humans' ACE2. Conversely, NeoCov efficiently infects human ACE2 expressing cells after a T510F mutation. So either somebody produces that mutation and then lets it out, or this virus figures out a way to make that mutation, then jumps to humans, and then becomes a problem. And you can say here that, well, it can do that, sure. Notably, the infection could not be cross neutralized by antibodies targeting SARS-CoV-2 or MERS-CoV. So now they're saying, now they're going in the danger zones. They said antibodies that are for SARS-CoV-2 or that are for MERS-CoV are not able to neutralize this variant of MERS-CoV. Now, the question in my mind, which is probably maybe in the whole um, thorough study or maybe not, is, are they talking about the neutralization after this mutation, or are they talking about the current state? And this is the last statement. Our study demonstrates the first case of ACE2 usage in MERS related viruses. They should have said over here once again bat ACE2 usage, shedding light on a potential biosafety threat of the human emergence of an ACE2 using MERS-CoV with both high fatality and transmission rate. They are saying that if this MERS-CoV learns to connect with human ACE2, just like SARS-CoV-2 learned it, then it can cause high transmission and fatalities as well, because it is not neutralized by human protection of SARS-CoV-2. That is the basic study here. So some of us will become worried about it, some of us will not be. I am not worried about it at this time. This is a study in a lab. I hope that whatever modifications they made, they destroyed the virus and it is just not out there. Okay, so stopping here for this topic. So Denise has a very valid point, and that is, why are they even tweaking and doing gain of function on any coronavirus now? Correct. They should leave this whole thing alone. They should not do these tests. This is, you take any virus and you attach the spike protein to it, and then you say, man, this can become dangerous. Yes, it can become dangerous. So you're correct. Nipa was correct as well, to leave these things alone. Stop creating more risk. So Caribbean child says, "Oh my God, more scaremong." Correct. And do me do me a favor. I presented it. I showed that there is actually not much reason to be nervous, but there'll be some who would present it as, "Oh my God, sky has fallen." And do an exercise. You'll see that those are the news where we naturally attract, and we go there, we get fear mongered, we get upset, then we come back, and then we become all scared. But this, I mean, you can take any coronavirus with a spike protein and you can modify it, and it can start binding with ACE2s or so on. Okay, so here we are. Carolyn says, my son tested positive with rapid test for 10 days. Positive rapid test is contagious. So praying for him, full recovery, and praying for all of you in the family as well to be safe, sound, and recover. Cool. So have a nice weekend. Please like, subscribe, and share. That would actually allow this video to spread a little more and maybe quell some of the fires that are going to start around NeoCov. If you would like to support this work, there are links in the description. You can buy me a coffee, or you can become a patron, or you can use PayPal. Thank you very much. And if there is no emergency in terms of NeoCov that occurred, otherwise I'll come back on over the weekend. If there is nothing, I will see you on Monday. And on Monday, we'll have Dr. Bruce Patterson with us with their latest data about the long COVID. Thank you very much. Have a nice weekend.